All right, so we are going to move on to our final operation in these combinations of random variables and constants. And so if you've watched the other videos, you should have a feel on what we're about to do, but if you haven't, here's what we're going to do. We were given our expected value in standard deviation of x. Our expected value is 3 and our standard deviation is 4. And we are asked to divide x by 4, which means we are going to be looking for the expected value of x divided by 4 and the standard deviation of x divided by 4. So what we've been doing is drawing kind of a visual to help us see what's going on here. So we are centered at 3. That's what we're told. We know that there are about 3 standard deviations on each side, which most of our distribution falls within. So we know that our distribution of x is going to be centered at 3, and most of it's going to be between -9 and 15. It's an ugly looking graph, but there it is. So we know that it's centered at 3, because that's what they told us. Now we're going to divide every point in this distribution by 4. That's what it's saying. Divide x by 4, so x can take on any of these values, and we're going to divide them all by 4. So if we do that, we'll take first our center, which is our expected value. So we're going to divide 3 by 4. A little simple calculation should tell you that 3 divided by 4 is just 3/4 or 0.75. So this distribution is going to now be centered at 3/4. So it's going to be around there. And we'll just say that since that is our expected value of x divided by 4. We're going to say that e of x divided by 4 is equal to 3/4. You can do that just by seeing that, or you can do it mathematically by saying that e of x divided by 4 is equal to the expected value of x divided by 4, which is what we just did. We took our 3 and we divided it by 4 to find this new center, and we get 3/4, which is the same thing. Now we're going to figure out our range here, our spread. What happens to that when we divide it by 4? So this our bottom number here is -9. Most of the numbers are there's not many numbers lower than -9. So we're going to say that -9, and we're going to divide that by 4. So -9 divided by 4 is -9/4, which happens to be just a little bit over -2. So we're going to say -9/4 is now the bottom point there. And our top point up here for our x distribution was 15. We do 15 divided by 4. And you would find out if you type that in your calculator and to get a mixed fraction. 15 divided by 4 is 3 3/4, which is just under 4. So we'll write 15 over 4 there. And so now we have this really compact distribution right there. You'll notice, obviously, that this blue distribution, which is our x, so our x distribution, ranged from -9, you guys see that? -9 to 15, which is a range of 24. But our x over 4 distribution has been shrunken in. It's been squished together. And so you'll notice that now most of our numbers are greater than -9/4, and most of our numbers are now less than 15/4. If you subtract these numbers from each other, this distance here, this distance between these ends is actually going to be 6. Happens to be 6, and you would find that by doing 15/4 minus -9/4 if you wanted to. But you'll notice that the relationship between 24 and 6 is coincidentally, if we divide 24 by 4, we get 6, which is exactly what it has happened. So we're going to say that the standard deviation, since it's a measure of spread, range is also a measure of spread. We're going to say that this distribution has shrunken down by an order of 4. So we say that the standard deviation of x over 4 is equal to the standard deviation of x over 4, which is just 4 over 4, which is 1. So our standard deviation has been reduced from 4 to 1 by dividing our original standard deviation by 4. This one is like our division example, which happened to be a negative number. Remember that we always want our standard deviation to be positive. So really what I should be doing here is writing absolute value of 4 just to make sure. But we always want our standard deviation to be positive because standard deviation represents a distance, and we cannot have negative distance. So just remember in this scenario that you are given a negative number, that we always want our standard deviation to be positive. You'll notice between the multiply and dividing that each of these operations to find the standard deviation and expected value for either of them follow exactly what the operation itself is. So if we're multiplying x by negative 2, we're going to multiply the expected value of x by negative 2, and then we're going to multiply the standard deviation by negative 2, and then take the absolute value of that, and we're going to do the same thing with division. So you guys can watch the addition and subtraction videos, also the multiply one if you didn't catch that. And that is it for this little mini series on how to combine random variables with constants.